Okay. Material properties of part design. Here,
Right.
uh, plastics are sensitive to operating conditions. Like the plastics molding processes allow parts designer more freedom than working with metals, because plastics materials are so versatile that you might be very
Right.
much aware that
Yes.
if we work with the metals, then we have a lot of constraints, a lot of restrictions. But in plastics,
Yeah.
we can work with plastic with variable temperatures, variable pressures. We can
Yeah.
mold its shape, but all these
Mm-hmm.
things not possible with metal. Like we cannot mold the metal, we cannot twist the metal, but here with plastic we can do all sort of things.
Right.
Like unlike metals, however, the mechanical properties of plastics are very sensitive to the type, rate, duration, and frequency of loading. This is telling us
Okay.
that when we load the plastic, so these things are very important, like the
Mm-hmm.
rate, how much plastic we are injecting within a second or within a minute. So that will be the
Right.
maybe volume per volume per minute we can calculate, or volume per second we can calculate. So that will be the rate, injection rate, or you can
Right.
say like flow rate, flow rate of the plastic,
Mm-hmm.
and then duration,
Right.
how much time it is
Mm-hmm.
taking, and frequency of loading, that how much time we are giving to complete a one cycle.
Yeah.
So the change in operating temperature and in some cases relative humidity. Okay,
Right.
the plastics part designer must take materials response to these conditions into account, because every plastic material behaves in a different way. Temperature
Right.
variation is different. One plastic melts at 500 degrees centigrade, another plastic melts at 700 degrees centigrade. Their uh,
Mm-hmm.
nature of flow is different. So when we design a mold, we
Mm-hmm.
always take consideration of these things, like
Right.
the physical properties of the plastics. That what is the
Okay.
melt flow index, what is the flowability of the plastic, what is the melting point of the plastic. So these things are different for different plastics. When we design a mold, we take consideration of these things, that how we have to accommodate our mold
Right.
according to a particular plastic.
Okay.
The table below lists the 5 typical loading operating conditions together with the relevant material properties a designer needs to consider. Here it is written very
Okay.
clearly. When we design,
Right.
we have to consider all these things when we design a mold. So
Right.
typical loading operating conditions together with the relevant material properties, like loading
Okay.
operating conditions, short-term loading,
Mm-hmm.
like um, stress strain, relevant material properties, stress strain behavior. Short-term loading
Right.
or long-term. Short-term is we are giving very little time for the loading,
Right.
and we are starting the another cycle in a very short time. So that is called
Okay.
short-term loading. So here
Right.
stress and strain behavior is important.
Yeah.
Maybe you might have studied the stress and strain graph. That is
Yes.
initially the graph. If we talk about the metals, then initial the graph is straight line, and then it moves into curves,
Deviates
deviates.
most in the curves. Yeah.
More. But in plastics, but in
Mm-hmm.
plastics, the behavior of the curve is non-linear from the starting point.
Okay. Okay.
It is not straight line from the starting, because the stress and strain is not directly proportional when we talk about the
Right.
plastics.
Okay.
Stress is not directly proportional to strain, but in metals, for a particular loading, until particular loading, stress is directly proportional to strain. Because of that we get a straight line.
Yeah.
we
Yeah.
will we will see that graph on a later stage. Okay.
Okay.
Long term loading, creep, stress, relaxation. when we go for long-term loading, like we holding the pressure for a long time to solidify the
Yeah.
plastic, because different plastics has their different properties. Some plastics take some few few seconds to solidify, while some plastics takes a few minutes to solidify. So until the plastic solidifies, we have to apply the pressure
Right.
from the nozzle side.
Right.
Okay, so that is called long-term loading. That we have to that pressure will be on the load on the mold itself.
Okay.
All that pressure, the mold will be under that pressure for the period of solidifying the plastic.
Okay.
So during that time, the mold will be under pressure, and because of that, this creep and stress relaxation comes.
Stress comes. Okay.
And repeated loading. This is
Right.
this is what actually creep and fatigue. These two very important terms when we talk
Yeah.
about the physical properties of any material, whether it is plastic, whether it is metal. So
Mm.
creep means we are applying the pressure for a longer time.
Yeah.
During that time, the metal loses its strength because of heavy loading for a long time.
During that time, the melt or the metal?
Metal.
You
I'm talk
mean
I'm talking
you
about
are talking about the inserts?
yes. I'm talking about the insert. Like I'm talking about the
Okay.
mold itself. The
Mold. Mold. Okay. Okay.
mold. So when you apply a pressure for a longer time, the mold
Yeah.
the
Loses its strength.
loses its strength. Yes, it starts losing its strength. So when
Okay.
we have to consider this creep when we are going for a mold which has long term loading.
Right.
Like we are designing a mold for such a plastic which takes much time to solidify. So
Yes.
what will happen that we have to uh, go for long term loading, and
Right.
when we will go for long term loading, we will have to consider this creep. Okay,
Okay.
when we go for repeated loading, like fast, very fast, when we are producing some
High production schedule.
yes, high, if we are working on a high production schedule, then we go for repeated loading, and then this fatigue comes into
Fatigue
the role,
comes into picture.
into picture.
Mm-hmm.
What happens that fatigue is like repeated loading, cyclic loading. We are applying the
Yeah.
pressure, releasing the pressure, applying the pressure, releasing the pressure. So then this fatigue comes into the picture.
Right.
So we have to decide that what is our working condition, what is
Uh-huh.
mold's working condition, and because of that we choose the right material
Right.
for the mold. Okay,
Okay. Mm.
so these are some mechanical properties which we have to consider when we design a mold, taking
Right.
taking into the account of the plastics, that which kind of
Yeah.
plastic
Yeah.
we are going to use.
Yeah.
High velocity and impact loading, this is impact strength. Okay,
Yeah.
loading at extreme temperatures. This is also thermal mechanical behavior. If some plastic melts at maybe 800 or 900 degrees centigrade, then the temperature will be very high. At that time, we have
Yeah.
to consider this loading at extreme temperatures. That like the mold material should be capable to handle that pressure and not to lose its
Right.
strength and its ductility.
Mm. Yeah.
So then this thing comes when we work on a high temperature, thermal mechanical behavior, and the material should also be very much, call it thermal heat transfer. Like the coefficient of heat transfer should be high,
Okay. Okay.
because we are working on a high temperature. So when we will start the cooling, the metal
Mm-hmm.
will start cooling very fastly. Like
Right. Right.
the heat transfer should be very high. Otherwise,
Okay.
it can distort or deviate the shape of the mold if the heat transfer is not high. So the thermal conductivity should be high at that time.
Yeah.